All right, so I have finished calculating my four measures of topography here. So here's my aspect data, which I showed you before. Here's my measure of roughness. So higher values, in this case darker pink values, should be more rough than the lower values. This is a measure of local variation. So is the ruggedness. So I guess it's not a surprise, they look very similar. They're calculated very similarly. I suspect by the time we get to the end, we're only going to use one of those. And then here is the slope, which steeper slopes, sharper inclines are in dark, and then lower, smoother areas are there in the blue color. So I've calculated these. I don't need to hold on to these all the time, so I'm going to highlight them all and right-click and say Group Selected. And I'm just going to call these Topography, and then close that up. So just so that they take up less room. Okay, so what we want to do now is fill in all of the sinks in our DEM. So any depression that doesn't have an outlet. And this may not be helpful for us in predicting gorilla habitat, but we have to fill in the sinks in order to calculate the flow accumulation in order to find our streams. So to fill in all the sinks, I'm going to go to Processing and Toolbox. And here we have a couple of different tools. This is the RGDAL tools that Q runs on. There's also an open source GIS called GRASS. It is super powerful but very complicated. It was designed by the Army Corps of Engineers. It's since being maintained by someone over in Europe, but it is very technical. Not user-friendly, but very powerful. So they've taken some of the tools from GRASS and incorporated that into QGIS. And Sega is kind of the same thing. This is System for Analyzing Geospatial something. It's an open source GIS. We're going to jump into Sega and look at hydrology. Oh, let's get rid of this. We're going to jump into Sega and come down here to hydrology, and right here, fill sinks. So I'll double click on that to open it up. Make sure that our input is the original DEM. I'm going to keep this as a temporary raster because I'm going to calculate something else from this before I save it, and then hit run. This is an iterative process, so it works through the data several times until it gets to a point that there are no depressions. Our data set is small, so it probably won't take very long. Oh, there we go. And here we are. It saved that inside topography, which is not where I wanted that. I'm going to close topography and drag it over here out of the way. And here is my filled DEM up on top. So it looks almost exactly like the original DEM. 99% of it probably is exactly the same. But if there were any depressions, those have now been filled, which is an important part of the next step, which I will show you in the next video.